Okay, so hello guys. Based on the previous discussion videos we were able to establish some mga basic and important nga concept nga kinahanglan mabalaan which is essential for the topic nga kinahanglan natin i-discuss bong. So let's start the discussion with this definition kag para mabalaan natin ang mga kinahanglan natin i-discuss for this discussion video. So first, let us define what is a motion. Motion refers to the change in position of an object in a given time interval. So that is referring to a continuous change in a position ng object. So this one refers to or pertains to a subject which is known as kinematics. So anong kinematics? It is a branch of mechanics wherein ang iyang concern is the motion of object regardless of a cause of that motion. So we have also to define what is a particle, anong particle or paano na siya natin gamiton in this discussion. So in an idealized model, that particle ang aton gina-consider will represent a moving body. No rotation, no change in shape occurs during motion. So ang pinakahapos Japon nga way to illustrate sa aton nga mga uh, problems kag mga kinahanglan i-discuss diri is through the use of rectangular or mga coordinate system. So that will be the mathematical method nga ginagamit naton to locate points in space or plane which will also be used for locating bodies as they move. So ang ating i-discuss ibang is focusing on the motion along a straight line. Or this one is referred to as our rectilinear motion. So we will start our study with the simplest type of motion a body can undergo. So kabalo kita that the particle or the body nga kinahanglan nato ni observe when we will be considering physics damo-damo isang possibility nga mag-move siya in a certain direction halin sa left to right or uh, projectile motion, free-falling body. And ang kinahanglan naton una-una i-consider ang pinakahapos nga type of motion which is the rectilinear motion. Both silingon straight lang ang aton nga path. This is called rectilinear motion or motion along a straight line. So para sa ating analysis, we will be considering the line of motion as the coordinate axis. So that is, ang ating x-axis will be considered the line of motion, either horizontal or inclined, or the y-axis if the line of motion is vertical. So, pwedeng horizontal, pwede vertical, pwede nakaslant. So, muna ato niya, i-consider kung ang ginatawag naton or ang ato niya gina-refer is a rectilinear motion. So, let's start with the basic concepts of rectilinear motion. So, first, we have position. It indicates the location of the body at any time as it moves. So the distance from the reference point along the path at any time. Usually given as a function of time like, for example, distance is multiplied is the value of your kung sa diin na ng specific mga body at a certain time. So the form of an equation depends on how the body moves along the line. So depende kung diin na siya. So for example, we have here, so at a certain time, diin na siya na yun sa aton nga graph. That will be, halin sa aton nga reference point diri sa aton x-axis, at a certain nga value sang time, diin na siya na yun nga value sang x. So, amo na ang ginalantaw naton nga position. So, in cases where the line of motion is the y-axis, position is denoted by y. So, sa aton di nga entire nga discussion, so, take note nga sari-sari nga mga books, sari-sari nga references ang pwede ninyo ma-encounter with regards to physics or mga sciences nga subjects. So, for this one, sa aton nga discussion, gamiton talang nga value for distance is x. Kay amo lang naton i-refer. So, we have also to discuss what is displacement. So the change in position of a body during a certain length of time or time interval. So displacement is different from distance traveled in the sense that ang displacement is a vector quantity directed from the initial to final position. Distance is the length of path followed by a particle. However, sa directional rectilinear motion, ang magnitude ng displacement is the same as the distance traveled. So, kung ang aton nga ginalantaw diri is rectilinear motion, so wala ta di problema sa diferensya sang displacement kag sang distance. But let me cite an example Okay, so as what I am saying, gusto ko establish kung paano natin ma-differentiate kag makita kung ano ang diferensya sang distance kag displacement. So this time, let me use some concept of a parabola or a projectile motion. So for example, this one, amo ni nga aton nga initial point, amo naman ni nga aton nga final point. So for example, ang mga ball for example passes through this line pakadto diri. Okay, this one, ari nga line, ang curve nga line will be your distance. But your displacement is halin sa aton nga initial pakadto sa aton nga final. So amo nang kinalain nila. So ang distance is ang total nga distance nga ginagyan gid ang specific nga particle. Ang displacement will be the distance halin sa imo initial pakadto sa imo final. So for example, we have a lot of vectors. For example, I consider we have this one, this one, this one, this one, and this one. Okay? So ang aton nga distance will be halin sa initial point naton pakadto sa final point. And this one dapat kung ano gid ang ginpangagyan niya nga distance. That is distance. However, ang ato naman yung displacement is halin sa initial pakadto sa aton final. So amo lang niya aton displacement, pila ni nga distance. So amo na ang kinalain or ang difference sang displacement kag sang distance. Another one, we have also time instant versus time interval. So anong kinalain nila? Time instant, the time at a certain point, that is at a time 3 seconds after starting or time 5 seconds before stops. So, manaka-specific gid. So, 3 seconds after siya naghalin, 3 seconds before siya mag-abot, so mga muna, time instant. How about time interval? So maghambal ta, so nakabutang 3 is interval. So for example, between 3 seconds to 7 seconds, so that is your time interval. Halin sa sina nga point, pakato sa sina nga point. But sa lingon, you have a duwa ka boundary sang time na kinahanglan i-consider. So, next, kinahanglan taman hiwaluon kung anong speed kag kung anong velocity. So speed defines how fast an object moves. Velocity is the rate of change in the position of an object. So the speed of a body including its direction of motion. Okay, so kabalo kita, kung maghambak kita velocity, dapat magina tan-aw na kita diri nga direction. So, another point that we have to familiarize is the concept of average velocity. Maghambak kita average velocity, this refers to the velocity sa aton nga body taken during an interval or between 2 points along its path. So, both silingon, that will be referring to your displacement divided by your time interval. So, or the change sa aton nga x divided by sa change sa aton nga time. Change sa aton nga distance all over change sa aton nga time. How about instantaneous velocity? Maghambal naman tayo instantaneous velocity coming from the word instant. It is the velocity of an object at a specific time or at a specific point along the path. So, amo nang ginhambal natin kagina. For example, at 5 seconds, di na nayon ang imong object, di na nayon ang imong car, di na nayon ang imong particle. So, amo na iya ko maghambal kita nga instantaneous velocity. So, we have a specific time considered, where x is the position of the given as a function of time. Velocity, take note, velocity is derivative of displacement. So for example, you are given functions. For example, displacement is equals to 1 half x squared x cubed plus 3x. So kung para mo kaumang values ang velocity, kinahanglan naton mag-derive. So derive mo ni mo kaumang values ang velocity. So for example, given naman ang velocity nga function, so para makuha ang distance, kinahanglan mo mag-integrate. So that's why ang ginhambal ko kinahanglan naton sang concept of mathematics diri sa physics. So another concept that we have to discuss and which will be essential sa sininga discussion video is the concept of acceleration. That will be the rate of change of the velocity. So liwat, we have speed. Kung mag-change na ang speed with regards to time, that will be velocity. Kung mag-change na ang velocity with regards to rate of change ng velocity sa object, that will already be acceleration. A body is seen or said to be accelerating kung ang aton nga body is changing. So we have also to consider nga may ara kita ginatawag nga average acceleration kag may ara man kita instantaneous acceleration pares man siya sa aton nga velocity. So ano ba silingon sa average acceleration? It is an acceleration of a body taken during a time interval or between 2 points along its path. So we have average velocity natin will be the change in velocity all over your time interval. So change in velocity all over your time interval. Okay? So for example, that will be final moving velocity minus initial velocity divided by your change in time. So that is your average acceleration. How about instantaneous acceleration? Same man Japan. Sa aton nga instantaneous nga velocity, we are referring here to the acceleration at a specific nga time. Okay? So take note, if i-derive pagid naton, so ang velocity, kung i-derive ta pagid ang equation sa velocity mo pa naton, acceleration. So take note, halin sa displacement, kung i-derive ta pag yung displacement, mahimo siya velocity. Kung i-derive ta ang velocity, mahimo siya acceleration. So take note of this. Sorry. So now, we will have uniformly accelerated rectilinear motion. So, ang tawag sa niyo yung shortcut is UARM. So, a very common and simple type of one-dimensional motion wherein ang atong acceleration is constant. In such case, at any instant within an interval, ang atong velocity will change at the same rate throughout the motion. So, but silingon diri uniform mga aton nga acceleration. So but silingon wala ka change, wala siya ga um, uniform lang katama nga aton nga acceleration. So basic nato nga kinetic nga equation for UARM is to perform this operation. So to simplify the equation, it will be assumed here that at time t is equal to 0, the position is 0 man. But silingon, wala siya naka-start pa sa imong mga ginhalinan at the same time, syempre zero man ang ating time. Thus, the time interval, so delta t will be the same as the time instant delta t. Because t initial is equal to 0, t final will be equal to t. So the displacement, delta x will also become same as the position. So, ang ginhalinan natin nga time, okay, initial natin nga time will be, tawag ko lang siya, ti. So, same man sa imong distance, xi lang man siya. Then, x final para sa final nga distance, t lang siya para sa aton nga final nga distance or pwede man tf. Okay? So, okay, so let us derive sa mga formulas na kinahanglan natin gamiton for the entire discussion natin for the um, calculations sa mga formula natin dari sa kinematic ng mga equations. So we have, kabalo kita if we will be looking for the average velocity, so we have average velocity will be equal to, so that will be the change in your displacement or change in mga distance divided by change in time. So pwede ito lang siya i-simplify as x, for example, divided by time. So let this be equal to your equation A. Next, for example, take note also nga pwede ta siya i-represent hamba ko kagina. So average nato nga velocity will be equal to your VF, final nga velocity plus initial nga velocity all over 2. So take note nga kung magkuha kita sang average, so amo lang man na final plus initial divided by 2. So this will be aton nga equation B. So we have both equation nga equal to average nga velocity. So pwede dito sila equate nga duwa. So we will have, okay, so x all over t is equal to VF plus VI all over. Okay? So, based diri, pwede natin kuhaon ang aton nga values ang x. So, aton nga values ang x diri or aton nga distance to be equal to VF plus VI all over 2 multiplied by time. Okay? So, this one, amo ni una-una naton nga equation or this will be aton nga equation 1. Okay? So, also, take note nga based on the concept of velocity and acceleration, we have a certain formula. So, ang imo nga final nga velocity will be dependent on your initial nga velocity. Ano siya kadasig nag-start plus kung ano siya kadasig nag-accelerate times a specific na time. So, we have this another equation kinahanglan i-consider. So, we have equation 2. Okay, so we have so halin diri sa aton nga equation, so we have 2 so halin diri sa aton equation, pwede naton ma-derive ang aton nga pwede naton siya ma-manipulate and we will come up with the equation. So ari, halin sa diri, we will have 2x all over halin diri so sa linon ko lang ang 2 may mo siya 2x. Papanaog ko ni ang t, we will have 2x all over t is equal to vf plus vi. So gidpasaka ko to ang 2, then ipapanaog ko ang t. So still the same man sa Japan nga formula. And based diri, pwede natin makuha ang formula for your VF. VF natin diri will be equal to 2x plus over t minus VI. And then this one, take note may ara kita duha ka equations ang VF, we have aring sa una kag ari sa kadua. So pwede natin sila duha ma-equate. So if we equate, we will have 2x all over t minus VI is equal to VI plus 80. And then, so simplify ta, we have 2x all over t is equal to 2vi plus 80. And then, if i-simplify ta pa siya, we will come up with the equation. So, multiply ko to ang t. So, we will have 2x is equal to 2vi t plus at squared. So, divide the both side by 2. So, x nato na nga nga distance will be equal to vi t plus, so divide ko ni by 2, we'll have 1 half a t squared. And this is also one of the formula nga pwede natin magamit. Okay, so okay, we have another pagiging formula nga pwede man natin magamit. So we have okay, so if tanawon ko niliwat nga equation, pwede ko manipulate kay kuhaon ko di ang values ang time. So we have, ang himuon ko, multiply ko to ang 2. So I'll have 2x all over vf plus vi is equal to time. Halin dere. So multiply ko to ang 2. So 2x, so silinon ko to ang time. So t is equal to 2x all over vf plus vi. And then, ang aring nga, kung values ang time, substitute ko siya sa dere. So, substitute ko siya. I will have VF is equal to VI plus A times 2x all over VI plus VF. Okay, so, I will have, so manipulate ko ang equation, I'll have VF minus VI is equal to A times 2x all over VI plus VF. Okay, so, I have, so sa linon ko ni sa babaw, so I'll have VF minus VI times VF plus VI is equal to 2AX. So I have here perfect nga binomial square of the difference of square, I mean. So, pwede niya siya ma-convert. So, square kong first, we have VF squared minus VI squared is equal to 2AX. So, pwede ko din ma-manipulate ang equation. I will come up with VF squared is equal to VI squared plus 2AX. Okay, so this one will be another natin nga equation. So take note, we have tatlo ka equation yung kinanglan, or apat ka equation yung kinanglan, matandaan. Okay, so another type of motion is the rectilinear siya nga motion, but we have free falling. So buot silingon, linear siya or nakalinya siya. But take note, halin kita, vertical na siya nga motion, papanaw. It will be free falling motion. So a free falling body is a one that moves vertically in the air under the action of its weight alone. So air resistance is neglected and there is no internal additional factor nga nagakos ang body to move except sang gravity. So busilingon, wala di friction, wala di sang iban nga consideration kundi ang nagapapanaog lang siya is through its weight. So the specific equation for free fall, so since same lang man siya, kung linear motion man siya, ang ginagamit ito rin formula was to be the same with the rectilinear motion na discuss natin nga apat ka formula. So, nga gin-derive natin nga apat ka formula halin sa original nga formula. So, but silingon, may ara kita limagid ka formula ang kinahanglan i-consider. So, still the same lang man sa Japon para sa free falling. So, take note nga ang kinahanglan lang natin islan is imbis nga x, mahimo na siya y. Imbis nga acceleration, mahimo na siya gravity. So, x. So, we have VI plus VF all over 2 times t. So, para sa free fall, mahimo siya y. So, amo lang mo nang ma-change. For this one, ang ma-change diri sa equation 2 natin will be the gravity kay may acceleration sa. For the equation 3, we will have, so we have Vf multiplied by time minus 1/2 your acceleration multiplied by the temperature, or the time I mean. So we will have same man dire, and ang x natin, himo na siya y, and then natin acceleration will be replaced by gravity. So we have, so same man na Japon for the third naton. So imbis nga x siya, himuon siya naton y. So take note, same lang ang mga formula. So dapat maging familiar lang kita kung kabalo kita kung paano niya siya natin i-manipulate ang mga certain nga equations. So kung for example, ginapangita sa imong distance, depende kung ano ang given. So dapat kabalo kita kung paano niya siya natin i-manipulate ang equation. So these are yung mga essential ng mga topics. So before kita mag-proceed with the example kung paano natin siya i-apply sa mga problem. So this is it para sa sininga discussion video. I will come up with another discussion video para sa mga example. So this is it for now. Thank you. Stay safe. God bless.